All right, back at it again with another geometry video. This one is using what my students have learned previously to now apply that knowledge to do a story problem. All right, they're going to get easier story problems than this one, and I'll go over an easier one than this one. But I wanted to start off with how an in-depth, like real situation can be figured out using some trig functions. Remember, I want my students to always be writing this. If they don't have it in their assignment, they should be writing it on a piece of paper next to them. So, katoa, sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent. Needs to be memorized. So katoa, so katoa, so katoa, so katoa, so katoa. Memorize it. Sing it in your head. Chant it. So, right triangle trig story problems. My students, for doing story problems, and for anybody out there, whenever you're doing a story problem, especially when it's a geometry story problem, you're probably going to have to draw it out. Or at least drawing it out will help you. So I'm going to end up, for this story problem, drawing the right triangle that the story problem creates. So the first thing, I'm going to go through and highlight the important information, underline it. So, Tony stole his dad's laser measuring tool from his work bag. He is using it to play with the neighbor's cat. He is pointing the laser through the neighbor's window, making it go bonkers. If Tommy is pointing the laser at a 26-degree angle of depression from his bedroom window, this might be important too, bedroom window, and the laser tool reads, so the laser reads 100 feet, about how far are the two houses apart? So the first thing is, we're talking about Tommy, who's got a laser pointer, who's in his bedroom, and he's pointing the laser into his neighbor's window to make their cat go bonkers, all right? He is being a little sneaky and making the cat go on drapes or run around in their house, whatever. It's chasing a laser, all right? So we have two houses. So that's gonna be my situation. So I'm gonna create some space up here to draw my situation. I got two houses. Now, there's a key vocabulary word in here, and like I said, this is why, I forgot the R in depression. Should be an R right there. My story problems I'll be giving my students will be a little easier because I won't be talking about depression and altitudes. But depression is pointing down. So Tommy is pointing, he's higher up and he's pointing the laser down. All right, so pointing the laser down somewhere. So let's say Tommy is maybe on the second floor of the house, or he's on the roof. I don't know. Tommy's sneaky. I don't know. But he is pointing that laser down. There's an angle of depression. Now that angle of depression is always from, if you're looking straight on. Angle of depression, straight on. Same thing if it was like angle of altitude, you always go from the horizon up or the horizon down. So the right triangle you would get from this, or at least the angle you would get from this, is that, because he's looking out there, but then he's going down to point the arrow or point the laser, all right? So we got this angle of depression of 26 degrees. And let me draw my little cat here, got little ears. All right, and he's pointing at the cat. So the other information is from Tommy, the laser tool, to the cat is reading 100 feet. So this is 100 feet. And what you can do is you now have this right triangle, and that right triangle can be used to solve for what the question is, and that is about how far away are the two houses. Because again, we don't know, like maybe Tommy is on the roof, maybe he's in the yard, maybe the cat is like in the middle of the house, maybe in the front of the house, we don't know. So it's about how far away. And about how far away they are would be this, wouldn't it? So we need to solve for that. So the first thing we have to identify is this 100 feet, right? We have adjacent, opposite, and hypotenuse. 100 feet is the hypotenuse because that is the longest side. That is the diagonal. It's across from the 90 degrees. This is going to be the hypotenuse. All right, now let's get rid of this question mark. This side that we want to find, because that's about how far away the two houses are, is going to be adjacent, right? Because it is right next to, it's part of, it connects, it's the adjacent side. And if you're not good with adjacent, you can always find opposite first and then, oh, okay, that one has to be adjacent because the other one's opposite. Process of elimination, all right? I know some people struggle with adjacent and picking adjacent. Just find the opposite, and then you got adjacent, all right? So, I'm gonna erase the story problem, which took me way too long to write. And we're gonna actually do the math to solve this. So, we have hypotenuse and adjacent. Hypotenuse, adjacent. We're going to use co. We're going to use cosine because we have adjacent and hypotenuse. Co. All right. So I set this up. I'm going to set up. We have the cosine of 26 degrees equals adjacent over hypotenuse. Adjacent over hypotenuse. So I don't know what adjacent is. Put an X there, I don't care. Put adjacent, it doesn't matter. Put a smiley face, I don't really care. We do know what H is though, and that's 100. All right, now my students' last assignment was they learned how to solve these. All right, so how do you get rid of division? You multiply, so multiply both sides by 100. Crosses out, and I get 100 times the cosine of 26 degrees equals A. Then a lot of my students are using Desmos. A lot of smartphones do have trig function on the calculator, and you can just type this in. My students need to be rounded to 2 decimals, so I'm going to do 100 cosine 26. Always double check that, yep, mine was in radians. You always need to have it in degrees when we're talking about degrees. That's a degree angle. So let's try it again. So I get 89.88. 89.88. And this is about, because the original question was about how far apart are the houses. Because again, we don't know where the Tommy is, we don't know where the cat is. We just know that Tommy's in this house, the cat's in this house, he's doing it. So about 89.88 feet apart. All right, that's a pretty in-depth story problem. Talking about the angle of depressions, angle of altitudes. A lot of the times I'm just gonna give the angle in the story problem. So let's quickly talk about one last story problem. And then I'll call it for the video. Let's just go with the famous tree problem, making triangles out of trees and shadows. What do you want to do? Let's find out how tall the tree is. All right, so let's do Jacelyn is tasked. I want to skip forward at this point because my video editing skills are not amazing. Jacelyn is tasked with determining yeah, that's right. I just spelled it right. With the height of a pine tree. Jacelyn knows that when she stands the tree, there is an angle You know what? We're just going to use altitude. Away from the tree. Up at a say 55-degree angle to look at the top Writing too fast. All right, if that is the case, all right. Jacelyn is tasked with determining the height of a pine tree. Jacelyn knows that when she stands 30 feet away from the tree, she has to look up at a 55-degree angle to look at the top of the tree. If that is the case, how tall is the tree? So the last one, Tommy was looking down, depression, pointing. Now Jacelyn's looking up. So let's draw this situation. We have a situation of, we got our pine tree, and then we got Jacelyn over here, and key, highlight the important information, 30 feet away from the tree. Look up 55-degree angle. All right. So, coming here with red, actually, we know that the distance from her to the tree is going to be, let's erase some stuff. From her to the tree is 30 feet. And we know that she has to look up at a 55-degree angle. Now, if that is the case, I need a change in here. This would be about, because we're not taking into account how tall Jacelyn is. Because technically, you know, she's not looking from the ground, but we're gonna do the math like she's looking from the ground. All right, we're not gonna account for how tall or how high up her eyes are off of the ground. So we have our 55-degree angle, and we want to find X over there. We want to find out about how tall this tree is. All right, so let's find out about how tall this tree is. SOHCAHTOA. I don't have the hypotenuse. This is hypotenuse. I don't have it. So that only leaves one. That leaves TOA. So we're gonna use tangent. All right, so I'm gonna set up the tangent problem. And this would be adjacent. This would be opposite. So we have tangent 55 degrees equals, let's see, we got tangent 55 degrees equals opposite over adjacent, so X over 30. All right, need to get rid of division, so we multiply by 30, cancels out, multiply by 30, so we get 30 times the tangent of 55 degrees equals X. Create a little bit more room to answer my problem. So come in, we're gonna do 30 tangent 55, and we get 42.84. And really, I'd actually probably let my students round to the whole number, because this is about, right? Because we didn't account for how tall Jacelyn is. Maybe she's looking from 4 feet, and we'd actually have to move that up and then add on 4. But we're not going to worry about that because we're remote learning, and that's too stressful. So we're going to be learning story problems, but we're not going to be doing them perfectly, just so that you have the idea of once you do need to ever do them perfectly, you just have to do a little extra, You're getting like 90% there. All right. So what was that? It was 42.8. So let's just say about 43 feet tall. All right. That's about how tall that pine tree is. I would say that you probably have to end up adding on how tall Jacelyn is. Like if I was wanting a perfect answer, you'd have to add on Jacelyn, which would be probably like plus, I don't know, 4 feet. That's a short person. But I don't know how old Jacelyn is. I don't know. Maybe she's middle school, or maybe she's a high school, or maybe it's 5 feet. I don't know. All right. Good enough though. Story problems. My students are going to get a lot more specific, a lot more laid out story problems than what I went over here. But this is the gist of it, is you need to draw, you need paper, you need a pencil, and you need to draw the story problem. You need to draw a right triangle that you will then solve. All right? Draw. Hope this helped. Definitely hope it helps my students that watch this video with how to draw stuff. If any of my students are struggling, please email me, contact me, and I can help you figure out how to draw the story problem. Thank you.